Hi guys, today I'm going to talk about LeetCode question 795, the number of subarrays with bounded maximum. The question is saying that we now have an array and L and R. L means the lower bound and R means the upper bound. The aim is to find the number of the subarrays that meet the requirement. The requirement is that the maximum of a given subarray shouldn't be bigger than the upper bound R and shouldn't less than the lower bound L. So let's take a look at the example here. We now have an array 2, 1, 4, 3 and 3 legal subarray. 1 is 2 and this is because its maximum is 2 and it's surely not less than 2 and it's less than 3. And another subarray is 2, 1, its maximum is 2, so it's a legal subarray just like former subarray. And the third one is 3, its maximum is 3 and not bigger than the upper bound 3, so it is legal. Now let's take a look at another subarray. Let's say 1, 4, 3. This subarray's maximum is 4, which is bigger than the upper bound 3, so the example is illegal. Let's take a look at a simple example here. In this example, all of the elements in the array are meeting the requirement. They are between 2 and 6, and there are 4 variables. I means the current index of the array, and J means start point of the array. And count equals to I minus J plus 1, which means which remember the last level of legal subarray. The rest is our result. Firstly, the element 2 comes in. Now we set I and J equals 0, and so the count is I minus J plus 1, which is 1. And the count means that now we have just one legal subarray in this level. And next we have 3, where at index 1 and J also stay at 0, and calculate the count equals 2, which means that in the level 2 we have 2 subarray, which is legal. You can see it's just the combination of the current element and the last level element. 2, 3 equals to 2 append a new element 3, and 3 equals just like a single element, which is totally new. And now we have a new element 4, and also increase the index. The count equals I minus J plus 1 equals 3. We have 3 new subarray 2, 3, 4, 3, 4, and 4. Next is 5. The count is 4. We have 4 new subarray. And the last one, 6. We calculate the count to 5, and which means that we have 5 totally new subarray, which meets the requirement. So the result here, we have 15 legal subarray. It's just like arithmetic progression, which is 1 plus 2 plus 3 plus 4 plus 5. So let's move on to a relatively sophisticated example here. The first element is 2, it meets the requirement, so the count is 2. Next element is 3, also meets the requirement, so we update the count to 2. Next element is illegal. Actually, it's a condition 2. The element is less than the lower bound, so we shouldn't update the count. In this level, the legal subarray is 2, 3, 0, and 3, 0. As you can see, it is just a combination of the current element and the previous legal subarray. And in this case, the single element subarray 0 is illegal. Next element 4 is legal, is condition 1, and update the count to 4. There are 4 legal subarray in this level. Notice this subarray 0, 4 is a combination of a legal element and an illegal subarray. Although the single element subarray 0 is illegal, but as long as it combines with the legal element, it becomes a legal subarray. Next element 1 is also an illegal. It's lower than the lower bound, so we shouldn't update our count, and it's just a combination of the combination of 1 and the previous level subarray. Next element 3 is legal, so we do update our count to 6. And the same idea applies to this level 1, 3. Even though 1 is illegal, but as long as period 3 is it can be regarded as a legal subarray. Next element 5 is also legal, so we just update our count I minus j plus 1, which is 7, and add it to the result. Next element is bigger than the upper bound, so we say that is condition 3. The element is bigger than the upper bound. In this case, we regarded this element as a gap, meaning that the subarray before this element can't connect it to the element after this element, because the subarray is the combination of continuous element. So as long as we have element 8, the subarray shouldn't be a legal subarray. And we just simply move the start point j to the next element, so move it to 8 and set count to 0, which means in the current level we have no legal subarray. The next element is 5. The count is I minus j plus 1 equals 1, and add it to the result. Notice that there are 2 5 subarray, although because the question allows duplicates, so although they have same value, they actually are different subarray because they have different start index and end index. Now let's take a look at the Java version of the code. The idea is simple and intuitive. There are 3 logical, there are 3 conditions. The first is a legal element. In this case, we just simply update the count I minus j plus 1 and then add the count to the result. The second case is that the element is smaller than the lower bound. In this case, we didn't update our count, we just add the count to our result. The third case is the element is bigger than the upper bound. In this case, we set the start point j to I plus 1 and then update the count to 0. So that's it. I know this question is a little bit counterintuitive, so please feel free to pause the video or rewatch it and comment down below our response as soon as possible.